of the second wiring. So we need to connect this point here at the bottom and this point there at the top together, and this will be our tap point. To do this, all we have to do is to carefully bend our two windings, bring them close enough, and carefully give them a twist. Just be gentle, not to damage the wiring. You don't need to tie them too tightly, because we will tin this after all. And I'm gonna make these two windings a little bit further apart, not that it matters too much though. And this is now our completed transformer. Notice the tap point. This is this side and this side are the points where our power will be splitted, and this side, this tap, will be connected to the first auto transformer we have built previously. It's not difficult to build, you just have to be gentle with these tiny wirings. But because we were using ferrite beds, these devices can be made very, very cheaply, lightweight and small. So here are the two transformers we have just built. Here is the auto transformer, the first part, and here is the splitter, the second part. So now I have built the circuit, and I have connected the tap of the first transformer, this is the first one, to the tap of the second transformer. Here are the outputs, the first output and the second output, and here is the input, and I have used a 50 ohm resistor composed of 200 ohms in parallel as a way to ensure that the input will be 50 ohms matched, because my simple generator here, my mini VFO, has to be loaded in 50 ohm to ensure a good matching. And also I have used this resistor as a standoff for the circuit. There are two pieces, two equal lengths of cable that are going to the oscilloscope, and I'm going to use this setup here to measure the performance of the splitter, roughly measure it. I didn't use 50 ohm resistors to ensure matching at the output of the splitter, because the oscilloscope I'm using has already 50 ohms internal resistors, so I can read directly at 50 ohms. So let's begin with the test. I have switched the VFO to a relatively low frequency, and nothing is connected now at the scope. So I connect one of these outputs, one of the outputs of the splitter. I connect them to the scope, and you can see the signal. Then I remove one of the outputs, the output that I have just connected, and I connect the other output, and here's the signal again. Now I have set the scope to trigger on channel 1, that's why you see the waveform going back and forth. So I connect both inputs now, and this is the result. There are two signals now that have the same amplitude and the same phase. So it seems that the splitter works okay. The frequency is about 4 MHz. So I'm going to try another frequency now, a higher frequency. This is about 7 MHz. This is 10 MHz. This is 13 MHz. Now let me open this a bit. 13 MHz. 16 MHz. That's 22 MHz. And now I'm gonna manually increase the frequency from the tuning knob even more. 23 MHz. 24. 25. 26. 27. 28. 29. 30 MHz. We can go a little bit further. 31. 33. 34 MHz. All fine, it seems all fine, but we haven't actually measured anything here. I don't know if you